Okay, welcome to part 2 of coffee houses and COVID-19. And so the theme of this part is, how does virus get into the air? Right? If we're thinking about airborne disease transmission, that's a really crucial question. Here on this slide, what I'm showing are several pictures of media representations of airborne disease transmission. And so I've already mentioned in part 1 a couple of these pictures. On the top right here is that a great editorial by Lindsay Marr about the coronavirus being in the air. And there's a picture of a fellow sneezing into a handkerchief. Up in the top left is another tremendous article by Shelley Miller. And again, the picture there is somebody sneezing. In general, if you Google for images of COVID-19 and airborne, you're going to find lots and lots of pictures of people sneezing. And for whatever reason, they're almost always sneezing from left to right. And the vast majority of them are male. I'm not going to comment on that. What I'd like to really point out here is that these pictures are extremely misleading about the threat of airborne disease transmission. And so why is that? I'm going to give you 3 reasons why they're misleading. And so the very first reason is that sneezing isn't even a symptom of COVID-19. So here on the right is a chart of all the typical symptoms of COVID-19 compared to other diseases like the common colds and the flu. Okay? And COVID-19 in particular, it's a respiratory pathogen. It infects your respiratory tract. Fever and dry cough are by far the most prevalent symptoms. Okay? If you look down here at the bottom, sneezing is not even a symptom. It's less than rare. Okay? And so it's very misleading to always, when you're talking about COVID-19 and airborne disease transmission, to always show a picture of somebody sneezing when that's not even a main symptom. It'd be kind of like if every time somebody with a broken leg was mentioned in the media, they showed a picture of somebody riding a mountain bike, right? Yes, you can get a broken leg from riding a mountain bike, but that's not the only means by which somebody breaks a leg. Same thing with COVID-19, okay? So that's the first reason why those pictures are misleading. The second reason is that people without any symptoms at all can transmit COVID-19. And that's one of the main reasons that it spread so quickly. There are so many people who are asymptomatic or pre-symptomatic spreading it. And just to really drive that point home, here's something called an epidemiological chart. And what this does is it lists several different patients associated with an outbreak. This happened to be a church in China. And so the index cases are patients A1 and A2. Those are the ones who spread it to the other ones during this particular outbreak. And they were believed to have been infected somewhere on January 18th. On January 19th, they went to a church. And the key thing here is that these 2 index cases had no symptoms when they went to that service. And they didn't have any symptoms for 3 to 5 entire days after the exposure. But so even though they were not symptomatic, patients A3, A4, and A5 who went to the same church on the same day got infected. Okay? And so these exposed individuals developed symptoms 4 to 15 days after exposure. And very intriguingly, patient A5 wasn't even in the church at the same time, but happened to sit in the same seat as one of the index cases. And so that's a really key thing. You can be talking with somebody who looks perfectly healthy, not coughing, not sneezing, but they're transmitting the virus and they're infecting other people. And so there's been a lot of great epidemiological research to try to figure out how many people are transmitting without symptoms versus who do have symptoms. And here, highlighted on the slide, is some work by Jeff Shaman at Columbia University. And according to his modeling, somewhere close to 86% of transmissions come from people with mild, limited, or no symptoms at all. So now you might be thinking, well, wait a second. If the infected individuals aren't coughing or sneezing, that's what it means to not be symptomatic. How does the virus get into the air? And so one potential answer is simply by breathing and talking. And the fancy word for all these things is expiratory activities. Expiration is the fancy word that means air coming out of your respiratory tract. So breathing and talking, how does that get virus in there? Well, we know that this can happen because we can measure it. So here on the side, I'm showing some images taken from some of my own group's research. So on the left is a cartoon schematic of a characteristic or representative setup. We have an individual breathing or talking into a funnel connected to something called an aerodynamic particle sizer. And that's a fancy, sophisticated piece of equipment that has a bunch of lasers inside. Long story short, it can measure very small particles that you can't see with the naked eye. And so there in the middle is a picture of my graduate student, Dr. Seema Asadi, doing some experiments with by talking into that funnel. And other people do this. Up on the top right, there's some work by Jonathan Reed in the UK. He actually has had people singing into an APS. On the bottom right, that's a fellow named Don Milton at the University of Maryland, College Park. He's got a really big funnel, and he's actually got it connected to a bio-aerosol sampler that not only can count expiratory particles, but can also measure viable virus that's carried in them. And so to show a little bit of representative data, here again is some work by my grad student, Dr. Asadi. And on the left, what we're showing is a graph of how many particles come out per second, okay, as a function of different types of expiratory activities. And on the left are various modes of breathing. And you can see nose breathing is very small, mouth breathing is a little bit more, deep, fast, and fast, deep, or whether you inhale quickly and exhale slowly, or vice versa. The key point here is that breathing emits a little bit, but speech emits actually a tremendously larger number of particles. And so here on the right, in the kind of reddish zone, we have quiet speech, intermediate speech, or really loud speech. And you can see that the louder you are, the more particles that come out. On the far right, we have a graph that shows the number of particles coming out and the characteristic size of these particles. So I mentioned a second ago that they're too small to see with the naked eye. And the horizontal axis here, that's the diameter of the particles, and it's measured in something called microns, micrometers. And you can see that the peak of these distributions, regardless of how loud you are, it's somewhere right around 1 micron. That length scale is really important because it drives home the third reason why all those media pictures of people sneezing is very misleading. And so here's this cartoon that I've shown a couple times. This came from a recent article published in Science by Kim Prather and colleagues. And it's a great cartoon, but it's also misleading. And so here's this cartoon that shows somebody talking, and you see this very scary looking cloud of huge red droplets being emitted, okay? And so this is what it looks like in cartoons. And what I'd really like to emphasize is that here's what it looks like in reality. In reality, you see somebody talking, you don't see any particles, or hardly any particles at all. And if you do see something, that's very rare, and that's not even an aerosol particle. The fact that you can see it means it's very large, relatively speaking. And so the key point here is that almost all of the expiratory particles emitted by breathing and speech are way too small to see with the naked eye. And so to really drive this point home, here on this slide I have a couple images of something that you know about. Here is, on the left, is the cross-section of a human hair, presumably it was from somebody with brown hair, okay? And so on average, the diameter of a human hair is somewhere around 1/10 of a millimeter. That's equivalent to 100 microns. Over here on the bottom right, you can barely see it, but if you look carefully, here is, to scale, a characteristic 1 micron expiratory particle. And so you can see it's so tiny you can barely see it compared to the diameter of a human hair. If we zoom in on this 1 micron expiratory particle, here I've now magnified it, okay? We can see here it's 1 micron. And what I'd really like to drive home is that even though these particles that you're breathing and speaking out are too small to see with the naked eye, they themselves are huge compared to the virus. So this little red dot represents, to scale, the diameter of SARS-CoV-2, which is the virus that causes COVID-19. It's only about 0.1 microns, which means you can literally fit about 1,000 of those virus particles in one micron diameter expiratory particle. And so you might be wondering about my color choice here. Why did I show this expiratory particle as kind of an ugly yellow color, right? Shouldn't it be blue or something because it's, liquid coming out? And the reason for that is it's very intentional, my color choice there, because what are these expiratory particles made of? They're not just water. The fluid that lines your respiratory tract is composed of lots of different proteins and salts, which are what a scientist would refer to as non-volatile. It means they don't evaporate. So yes, inside your body, all of the respiratory fluid has lots of water, but these droplets, as soon as they're emitted out into the air, they very rapidly, within fractions of a second, evaporate. All the water leaves, and it leaves behind all the non-volatile stuff, basically the mucus, all right, the dried proteins and salts, and the virus hangs out in there as well. And so to really illustrate how these expiratory particles form, here on the left, we have a schematic of the human respiratory system, okay? And there's basically 3 places where these particles can form. And starting up on the top, the one that probably most people think of is the so-called oral mode. Sometimes when you talk, you do have spittle. You can see large droplets that are emitted. You might have heard the expression, say it, don't spray it, right? Those are, the fact that you can feel them and see them means, relatively speaking, they're huge. Way bigger than 30 microns, maybe up to even millimeter scale, right? And so that's the so-called oral mode. It's formed mostly of saliva from your mouth. What most people don't realize is that you can also form expiratory particles in 2 other places. One place is deep in your lungs. There's something called the bronchioles, okay? And there, the respiratory fluid, the lines, the little channels where oxygen and carbon dioxide are exchanged in your lungs. When you inhale or exhale, those channels expand or collapse. And when they do that, and when they pinch off, they can effectively form little droplets that then get exhaled. That's the second place. The third place is right here in your vocal cords, okay? And so what I'm showing here is a certain type of video called stroboscopy, where they use flashing bright lights, and they are looking right at your vocal cords, okay? And so when you just say, ah, what's actually happening inside of your larynx, inside of your vocal cords, is there's a couple little flaps that are going back and forth like this very quickly, okay? So I have a kind of a deep voice. The frequency is about 120 hertz, which means that when I say ah, my vocal cords are doing this 120 times per second. It's very fast, okay? Here's a video, and to me it looks kind of like a little alien, all right? Well, this is just a healthy human woman, all right? And it's not showing it in high speed. This is, again, there's flashing lights, but hopefully you can see that these vocal folds are going like this very quickly, okay? And there at the bottom you can see a little cartoon of what happens to the fluid that's lining the vocal cords, and it's creating these little droplets that are then exhaled out into the air. And so I think a lot of people are unaware that just talking causes these particles to be emitted. You can't see them. A lot of people have never seen a video of vocal folds or vocal cords doing this, right? But it's very well established in the scientific literature that this happens, that these droplets are emitted. So I mentioned that if asymptomatic people are not spreading it by coughing or sneezing to a great extent, it might be breathing, it might be speaking like I'm showing here via vocalization. Just to really complete the picture, going back to another mode of aerosolization of virus, I'll just very briefly mention that there are other ways that have nothing to do with expiratory activities, nothing to do with breathing or speaking, how to get into the air. And I mentioned this idea of aerosolized foamites, which is a fancy way of saying contaminated dust. And so this is some work my colleagues and I did very recently. On the left is a video of my student holding a Kleenex, a contaminated Kleenex. And she's just rubbing it gently by hand. And she's holding it in front of an aerodynamic particle sizer. And so this video on the right, this shows the number of micron scale aerosol particles emitted by this Kleenex as a function of time. And you can see that when she stops moving her hand, the particle count goes towards 0, and then she starts crumpling it, it shoots up again, and then she stops and it goes down. So there are tremendous, again, people don't think about this because you can't see it. This is not dust that you can see floating around in the air. This is micron scale particulate matter that you can't see. Something like rubbing a contaminated Kleenex launches thousands of particles into the air. And our other research, which there's a great Wired article here about this, which you can read if you're interested, shows that, at least for influenza, these contaminated dust particles can carry a viable virus. Yeah. That research was with influenza. Here on the right, I'm showing a couple recent articles specifically about COVID-19, up on the top right, there's some work by Liu et al. Where they went around sampling hospital air in China. And surprisingly, they found some of the greatest airborne concentrations of SARS-CoV-2 were not in the patient rooms, but were in the rooms where the healthcare workers were taking off their personal protection equipment, taking off their masks, taking off their gowns. And they hypothesized that, well, maybe that's consistent with virus being aerosolized on the dust. When you take off a shirt, okay, or if you just go like this and rub your sleeve, you can't see it, but there's a lot of stuff being launched into the air. And if I had sneezed into my shoulder there, potentially that'd be getting virus into the air. And here on the bottom right, there's another recent report where they went around and sampled with swabs different surfaces in a hotel room, or a couple of hotel rooms known to be occupied by people who had been infected with COVID-19. And they found some of the highest concentrations of the virus on the pillowcases and on the duvet cover and the sheets of the bed that they slept in. And it's known from other research, at least with influenza and other things like that, that simply shaking a blanket, for example, can launch virus into there. So to summarize part 2, how does the virus get into the air? I want to emphasize that we don't know for a fact, we don't have any direct evidence for any particular mode of airborne disease transmission. But there's a lot of indirect evidence suggesting that if you look around a cafe, what are the things you most need to worry about? The one I would worry most about, and I made the picture here big to represent that, is vocalization. People talking, people speaking, people singing, even breathing, those can potentially be the biggest source of transmission from asymptomatic people. Now, that doesn't mean that you shouldn't worry about these other means. Clearly, if somebody coughs in your face or sneezes, they're also emitting lots of not only big droplets that you can see, but also small expiratory particles. So I'm not trying to say don't worry about coughing. Of course, that's a big concern. And I also mentioned this idea of resuspension of dust. That's also a potential mode of transmission. There's not a lot of science on that yet, especially for SARS-CoV-2, but it is also a potential area of concern.
Okay, that brings us to the end of part 2, where we talked about how the virus gets into the air in the first place. Next, in part 3, we're going to talk about an even more complicated topic, which is what controls the probability that you'll end up getting infected by that virus. So please stay tuned for part 3.